Okay? So you see this point? This is very clear? Right? Okay. So now this will be, so what will this quantity be? What will be yt minus expectation yt? Yt minus alpha upon 1 minus phi. Which is what? Which is this whole thing? Right? Which is this whole thing? Which is et plus phi et minus 1. So on into what will be yt minus 1 minus expectation yt minus 1? Perfect. Et minus 1 plus phi et minus 2. Sure? Is this clear?
Yes.
Now, if I multiply them, what will I get? First, I'll multiply all terms with et. Et minus 1, et minus 2, et minus 3, et minus 4, etc. So, all those terms will be cross terms, et into et minus 1, et into et minus 2. The exponent of all those terms will be 0. Because all those are covariances of et with its past values. Covariance of et with et's, right? Okay. Next term will be I multiply with phi et minus 1. So what will I get? Phi et minus 1 into et minus 1. I will get phi et minus 1 square plus phi et minus 1 into phi et minus 2 and so on. So again all the cross terms will be there. The expected of that cross term will be 0. So what will remain? Phi et minus 1 ka expected value. Right? Okay. Now similarly, if I multiply with phi et minus 2, yeah, if I multiply with phi square et minus 2, what will I get? Phi cube et minus 1, et minus 6, so on and so on. So I will really get terms like this. It's expected value of phi et minus 1 square plus plus when I multiply with et minus 3, what will we get? 5 raised to 6. 5 raised to 5. Right? 5 raised to 5. Et minus 3 square and so on. Right? Okay. An easier way to see this. Okay, so if I keep on doing this continuously, right? If I take this out, what is the next term? If I multiply 5 raised to 4, I mean et minus 4, what will I get?
5 raised to 7.
5 raised to 7.
5 raised to 7. So on, right? Okay. Where all these squares are nothing but the variances. So I will get something like, so this will be equal to phi square, okay, fine, so this will be equal to phi, this will be equal to phi sigma square e plus phi raised to 3 sigma square e, right, plus phi raised to 5 sigma square e plus phi raised to 7 sigma square e, and then you would guess the next terms, phi raised to 9 sigma square e and phi raised to 11 sigma square e and so on. Right. Now here I can take phi sigma square e common. Right? I take phi sigma square e common. So what do I get? I get phi sigma square e 1 plus phi square plus phi raised to 4, right? Plus phi raised to 6 plus phi raised to 8, so on. Sure? Right? 5 raised to 8, so on. Okay. Now this is nothing but this is equal to 5 sigma square into 1 plus 5 square plus 5 square square plus 5 square cube, so on. You see? This is nothing but 1 plus 5 square, right? Plus 5 square square plus 5 square cube, so on. Which is what? Which is 5 sigma square e upon 1 minus 5 square. You see this point? Sure, friends? Confusion? Where are you confused?
I confuse the powers.
Okay. Okay.
So that will be E minus 5, right? 5 is equal to
ET minus 5. ET minus 5. Yeah, 5 raised to 4, ET minus 5 and so on. You're right. Yeah? So you see, this is okay for you?
Yeah.
This is okay? Oh. Now from this, I get this 5 sigma square E plus 5 cube sigma square E and so on and so on.
Yes.
Right?
In the next step.
In the next step, if I take 5 sigma square E out common, I get 1.
Plus
5 cube का 5 square होगा.
yeah.
5 raised to 5 का 5 raised to 4 होगा.
Right.
5 raised to 7 का 5 raised to 6 होगा. 5 raised to 8, 9 का 5 raised to 8 होगा. And so on. Now this can be written as 5 raised to 4 plus 5 raised to 5 square.
Yeah.
Sure. Similarly, 5 raised to 6 minus 5 raised to 2 raised to 3.
Okay. So a square, the whole cube is a raised to 6. However, a square plus a square into a cube is equal to a raised to 5.
Sure. So what is this? This is nothing but 5 raised to 6. This is 5 square cube. So 5 square into 5 square into 5 square is 5 raised to 6. Right? And so on. Which is nothing but 5 sigma square E upon 1 minus 5 square. So the point again is, you see, if phi is equal to 1, this math doesn't work. So the covariance yt minus 1 is not conceptually thought of. You don't get covariance yt minus 1, right? But if phi is less than 1 absolute value, you get the covariance between yt and yt minus 1 as phi sigma square E upon 1 minus phi square, which is not dependent upon t. Which is not dependent upon t. Right? Which is not dependent upon t. Sure? Now, so what is this? This is gamma 1. This is the covariance between yt and yt minus 1. If I ask you to find out the correlation between yt and yt minus 1, what will you do? This first. This is called autocovariance of order 1. This is called autocovariance of order 1. This is called autocovariance of order 1. Right? Why autocovariance? Because the covariance between yt and yt minus 1. This is called autocovariance of order 1. Yt minus 1. Right? What do you think will be the correlation between yt and yt minus 1? How do you get correlation between x and y? You divide the covariance x and y by the standard deviation of x, standard deviation of y. So to get the correlation between yt and yt minus 1, you divide the covariance of yt minus 1 by the standard deviation of yt and the standard deviation of yt minus 1. Okay? But because yt is a stationary process, the standard deviation of yt and the standard deviation of yt minus 1 are the same. So you divide by the standard deviation of yt into the standard deviation of yt is the variance of yt. Right? So, the covariance you get is now an important idea which I will call rho 1. Rho 1 is to find out correlation between yt and yt minus 1, which is rho 1 yeah. But what is covariance yt minus 1? The whole thing divided by
Sigma square y.
yeah. So what remains? What remains? Phi. Phi is called the autocorrelation coefficient. That is, this is autocorrelation of order 1. The correlation between yt and yt. So if my process is, if my process, friends, is, if I tell you that my process is 2.5 yt minus 1 plus et, and et is a standard normal process, what do you think will be the covariance between yt and yt minus 1? If I told you to find out the covariance between yt and yt minus 1 for this process, what will be the covariance between yt and yt minus 1? There is a covariance, no? Et is a standard normal. So what will be sigma square E? 1. So the covariance will be, covariance yt minus 1 will be 0.5 upon 1 minus 0.5 square. And what will be the autocorrelation of order 1? That is 5, 0.5. 0.5 is 5. Right? So if I ask you what is the correlation between yt and yt minus 1, you will say 0.5. If I tell you what is the covariance between yt and yt minus 1, you will say it is 0.5 upon 1 minus 0.5 square. 0.5 upon 3 by 4. So 1 upon 2 by 3 by 4. So 1 upon 2 into 4 by 3. So 1 upon 2 by into 4 by 3. So which is 2 by 3. Which is 2 by 3. Right? Covariance is 2 by 3. Whereas correlation is 0.5. Now, so this is called. Now if I ask you the covariance between yt and yt minus 2. Yeah? If I ask you the covariance between yt and yt minus 2, how will you get it? If I ask you the covariance between yt and yt minus 2, that is, your model is
Will that be what is autocorrelation for order 2?
autocovariance of order 2.
Right, right.
Okay? It will be alpha. Right? I am asking you covariance yt minus 2. Which will be, alpha cannot be have any covariance with yt minus 2, so that will simply be alpha plus phi covariance of yt minus 2 is alpha will stay as it is, phi into the covariance of yt minus 1 yt minus 2 plus covariance of et into yt minus 2. Right? Covariance of et into yt minus 2. Now, what is et? Et is the value of the shock to the system today. What is yt minus 2? The value of y 2 periods back. The shock today has nothing to do with the value of y 2 periods back. And therefore, this covariance can be safely taken to be 0. Right? So, you get this one. Now, what is this? This is covariance of yt minus 1 and yt minus 2. What is the difference in the two time periods? 1. Yeah?